Okay, so in the last lesson, properties of exponents. What do you do when you raise a power to a power? What's the operation? Multiply, right? So this would be z to the 8th. Oh, sorry, 15th. Yeah, I just did the wrong thing. To the 15th. Okay, so m to the 40, v to the k to the, okay? Right. The next thing is, what happens when you've got a power outside of parentheses? What do you do with that power? I mean, you could think of it like distribute, right? You're going to put it on everything that's inside the parentheses. So this one becomes q to the 4th, r to the 6th to the 4th. Okay, but the r to the 6th to the 4th, we use that property. What is r to the 6th to the 4th? R to the 6th to the 4th. Right, so this is q to the 4th, r to the 24th. What about this one? What is anything to the 0 power? 1, right? This one, you actually don't have to distribute the 0 because the whole thing is 1. Done. Right? That was the first page. The next page is, what do you do when you divide the same base raised to different powers, right? What's the operation between the exponents? Subtract, right? That's x to the 7 minus 4, x to the 3rd. Okay. Let's see if there's one interesting. What about m to the negative 3 over m to the negative 5? What do you get when you do the subtraction? Positive 2. Good job. Right, that's m squared. None of them are very interesting. So what if you have a power outside of parentheses, just like we did on the last slide? What do you do with the power? Distribute it, right? Just put it on everything that's inside. Now, in this case, probably before we do that, you can simplify 12 over 15. What's 12 over 15? Simplified as a fraction, like you just did in the worksheet. 4/5, right? And actually, we could simplify p to the 3rd over p. P to the 3 minus 1, 2, right? So this is actually 4 p squared over 5. Okay, now raise it everything to the 4th power. And again, what do you do with that 4th power? Distribute onto everything that's inside the parentheses, right? That's 4 to the 4th, p squared to the 4th, which is p to the 8th, and 5 to the 4th. Okay, what is 4 to the 4th? 4 times 4 times 4 times 4. It's like saying, what's 4 squared times 4 squared? 16 times 16. Not a normal one that we would know, but 256. But easier, maybe more likely if you knew 5 to the 4th. What's 5 squared times 5 squared? 25 times 25. 625. So this one is 256 p to the 8th over 625. Okay, how do you simplify a negative exponent? Usually, what do we say to get rid of? You flip, right? Anything that's in the numerator goes to the denominator. Anything that's in the denominator goes to the numerator. When you have this kind of thing here, then just flip the fraction, change that to a positive. A to the 5th, b divided by a, b to the 3rd, raised to the positive 2. Okay, and now you can simplify that. A to the 5th over a is a to the 4th, b over b to the 3rd, b to the negative 2, which means divide by b squared. Right? So that would be a to the 4th over b squared squared, which is a to the 8th, b to the 4th. All right, so those are all the properties of exponents. We did them in 2 days. Right, there are things that will come up a lot. that leaves us with one more thing to do, which is very basic. There's not that many slides to it. Simplifying radicals. Meaning without turning them into decimals in a calculator. Simplify a radical. And in this case, simplify a square root. Right? If you try to take the square root of 48, you've got to be thinking, is 48 a perfect square? Is 48 the result of a square? The answer is no. So you look for, does it have any factors that are perfect squares? And it turns out that 16 times 3 is 48. 16 is a perfect square. So you simplify it by breaking it up into 16 times 3. And you can simplify the square root of 16. That's 4. That's what we mean by simplifying a radical without turning it into a decimal. Now, you may have done in earlier years more like this. Okay, that would be 2 times 24. And that would be 2 times 12. And that would be 2 times 6. And that would be 2 times 3. You know, break it into a factor tree, get it all the prime factors. And then for every 2, you take out 1. Is that how you learned that before? It's not, once you get into algebra, you're not going to be making factor trees. You need to be able to do this kind of thing. And a lot of this kind of thing really comes down to, do you know your multiplication tables? Because if you do, it's easy. What do you need? Okay. Just her? No problem. So, yeah, all of these, Galen, right? All of these are in the multiplication tables we've been practicing with all semester, right? If you, as long as you know these perfect squares, you know, you can do most of the ones you're ever going to get, right? 1 squared through 12 squared. Those all came up. So you don't have to think of them like something different. They're just part of what we already know. Now, if 2 squared is 4, remember, we're actually interested in the opposite of that, taking the square root of 4, right? So if 2 squared is 4, the square root of 4 is 2. If 5 squared is 25, then the square root of 25 is 5. So we're going to use our knowledge of the perfect squares to go backwards, and that will simplify the radicals. Right? So all of these here, as long as you keep those in your mind, you'll be able to simplify any of the radicals that we deal with. Right? The square root of 160. So you think, well, is 160 a perfect square? No. Are any of these perfect squares factors of 160? Look in the list. There's an obvious one. 16, right? I mean, 160 is 16 times 10. So if I can split this up into 16 times 10, and then take the square root of both of those, what's the square root of 16? 4. So there's your answer, 4 root 10. Right? You got to just think of your multiplication tables to find the factors that will simplify. How about 72? Any factors of 72 that are perfect squares? 9 is a perfect square. Okay, so what happens if I say, okay, let's do 9. 9 times 8. That'll give me 3 times the square root of 8. Okay, then you got to ask yourself, is 8 simplified? Or can you simplify the square root of 8? Does it have any factors that are perfect squares? 2 is not a perfect square. What about 4, right? So in fact, you know, 9 is okay, but it's actually not the greatest factor of 72 that's a perfect square. Right? We would have to take another step and do this. Now it's 2 times the square root of 2. And we still had this 3. So that's 6 times the square root of 2. You know, usually if you're going to go in this list and look for a factor, which is a perfect square, which is a factor of the number, you need the greatest factor, which is a perfect square. And, 72 would fit right here in the list. So I would just start dividing. 72 by 64 doesn't go evenly. 72 by 49 doesn't go evenly. 72 by 36, that goes evenly. So you start at the top and go down so you get the largest perfect square. Right, so I would have taken this thing here and gone, that's 36 times 2. The square root of 36 times the square root of 2 is 6 root 2. Okay, then we can also do the same thing with fractions. Okay. If I have the square root of 36 over 49, I can split it up into the square root of 36 divided by the square root of 49, both of which happen to be perfect squares. So that's 6 over 7. So in the first couple slides, we broke it into factors, right? And this time we're breaking it into a quotient, into two different radicals. For example, the square root of 64 over the square root of 49. I mean, you should look at those numbers right away and say, those are perfect squares. In fact, at that point, you could probably simplify this in one step. Now, they showed another step in between. They showed this step in between. And what would that be? The square root of 64 is 8. The square root of 49 is 7. You might just go right to that step, and that would be fine. How about this one? The square root of 144 over 9 equals 12 over 3, which is 4, which tells you what is 144 divided by 9. If the square root of it equals 4, then this is 16. So we could have actually simplified that inside the radical. That's the square root of 16. But makes the point anyways. Okay, what if you had something like the square root of 72 divided by the square root of 50? Where neither one of those are perfect squares, right? But can they be simplified? I mean, we already did 72. 72 was what? 36 times 2. How can we break 50 into two factors, one of which is a perfect square? Kayleen? 25 times 2, right? So we would say that's the square root of 25 times the square root of 2. And now these square roots of 2, that's just like simplifying a fraction. Divide out a common factor. And then the square root of 36 over the square root of 25 is 6/5. Okay. So the homework, last homework, page 291, 1 to 6, 24 to 26.